Hello and welcome to this video. In this new chapter, we'll be looking at binomial expansion. Now, if you're not sure what binomial expansion involves, it's simply a plus b in a bracket raised to some power n. In year 12, we look at expansion of this bracket where n is more than just 2 or 3. We know that if it's a 2, it's going to be quadratic, and if it's a 3, it's going to be cubic. But there are the larger values of n that you can evaluate this expression for, and there is a rather simpler formula than going through algebraic expansion of brackets and multiplying algebraically. We're not gonna look at that and look at some other details involving Pascal's triangle, evaluating factorial notations, and as such that will help us to evaluate those brackets where n is a positive natural number. Of course, in year 13, you look at expansion where n is a negative value or has a fractional negative value and as such. So we're not going to bother with that for now, but let's get into starting just using n as a positive value in this algebraic expansion of this binomial expansion of this bracket. So we close the video, have a go at these questions, and then I'll play the video and check your answers with me. Yes, for you've had a go at all of these questions. You do have to expand part for question one. You do have to use the told you before where you use a box method and as such evaluate the expansions here. So if you're not sure what to do here, you would just write x minus y in one bracket, and the other two brackets where you have x minus y times another x minus y, you just evaluate these two for x squared minus 2xy plus y squared, and then you can use the box method here to tidy things up. You write x and a minus y here. That's this bracket that I'm writing vertically than horizontally, so that we'll end up with 6 terms here. Now, don't confuse your answer with the question. The answers will end up in these purple boxes that I'm drawing here. The rest is a question. All right, so you'll have x cubed here. You have negative 2x squared y, and here you negative x squared y. That's why it will get add up to negative 3. And here you'll have a plus 2xy squared, and here you'll get plus xy squared, and finally you'll have a negative y cubed here. That's why your answer, when you add these two terms together, because their powers are the same, and you add these two together, you end up with such an expression where you have, I'm going to rub off my working out and show you this will be the answer here. All right, and finally you would perform the same methodology for part C. I would expand two brackets first and then the third factorial. So the third bracket you multiply out, and for two, well, you would get this expression here. And for question two, you just have to be sure to know your index flows. Here, the power of 3 will be distributed to whatever is inside the bracket here, because there's time sign between those two. Minus 2 cubed is minus 8, so that would be the answer there. And 3 to the power of minus 4, you could write it in the denominator with the 3 to the power of 4 is 81. That's why we get a reciprocal of that because of the negative power. Okay, so I've explained these in more depth in chapter 1, where we dealt with negative and fractional powers. So 2 here, you distribute the power bracket to every term inside that bracket, because there's no plus minus sign here. This is not binomial expansion. This is just the evaluating, you call this one term inside this bracket because they are just multiplying. So it'll be 4 over 25 x squared. Next one, you would flip the fraction because the negative power and x will go in the denominator rather than the numerator. So 3 to the power of 3 is 27. It will come to the top. Now, okay, so for question 3a, uh, fractional powers here, the first power of a half means the square root, so you write it like so. The negative power means send it in the denominator, take the cube root and square it, because you have 1/3 as you can break that up. I've explained that. So that's right, negative a third times by 2, so that's why we cube root. Gonna cube root 64 is going to give us a 4, and then square it. The square of 4 is going to give us 16 in the denominator. Everything goes in the denominator because uh, all of this is up in the numerator, and the negative power will send it in the denominator. For x, you could have written this as 1 over 16x to the power of 2/3. It would have been similar, but that's better for you to understand that you're taking a cube root and then it's the same as having a cube root first. Now, the order of that is the same. You can test it with your calculator. All right, so I'm not going to talk about these anymore. They are simple enough to understand. I'll see you in the next video.